Alright guys, so several of you guys requested on this conceptual practice sheet I gave you a little answer key, so I figured we'd work one up together. Remember, when you're explaining these things, you're trying to explain these hows and whys and explain in details. So looking at this first question, explain what happens when you change the number of protons in an atom. So, when changing the number of protons in an atom, if you change the number of protons in an atom, you change the element. Reason for this is that we know each element has a certain number of protons in it. But that's not the only thing it'll do. It will also change it will also change the mass of the atom, because the mass of an atom is equal to the number of protons and the number of neutrons. So this is like a really good detailed answer, and please do not think like these are answers like you have to memorize these answers. So pretty much like what I'd be looking for if I asked you to explain what happens when you change the number of protons in an atom. And what happens is it changes the mass of the atom, because the mass of an atom is equal to the number of protons and the number of neutrons, and it changes the element because each element has an assigned atomic number. You change the number of protons, that's what the atomic number is. It's a different way of saying it, or you go with what we have here. If you change the number of protons in an atom, you change the element. Each element has a certain number of protons in it. It will also change the mass of the atom, because the mass of an atom is equal to the number of protons and the number of neutrons. So the two big ones. First, it changes the element. Why? Because each element has a certain number of protons. Second, changes the mass, because the mass of an atom is equal to the number of protons and the number of neutrons. Alright? See if I can do this and make it work real quick for me. Alright, so explain, on number 2, explain what happens when you change the number of electrons in an atom. Changing the number of electrons in an atom.
Bella Calusi, Allie Laney to the office.
Develop, cause, create a charge in the atom. An atom starts with the same number of protons, which is the positive charge, and electrons, which is negatively charged. I would take that right there. I'd be happy with that, because changing the number of electrons in an atom will develop a charge in the atom. An atom starts with the same number of protons, which is the positive charge. We should say which is positively charged. Let's change that. So changing the number of electrons in an atom will develop a charge in the atom. An atom starts with the same number of protons, which is positively charged, and electrons, which is negatively charged. So gaining or losing negative charges is going to affect the charge. Alright? Not too bad. How about this one? So let's look at this one. So number 3 that I gave you is explain. Oh, man. Explain how you know that electromagnetic radiation is a wave. So explaining how electromagnetic radiation is a wave, what proved electromagnetic radiation is a wave? In the double slit experiment, electromagnetic radiation such as light was passed through two slits. On the back end of the wall, you showed an interference pattern, which is a property of waves. The interference pattern was there because of the constructive and destructive interference between the two waves radiating out from the two slits. Okay. So explain how you know that electromagnetic radiation is a wave. In the double slit experiment, electromagnetic radiation such as light was passed through two slits on the back end of the wall, showed this interference pattern, which is properties of waves. The interference was there because of the constructive and destructive interference between the two waves radiating out from the two slits. You can go a little farther here if you'd like and explain this constructive and destructive interference a little more, but I'm pretty sure I asked that later on down. But you can add that extra detail in there talking about constructive, the same points of the waves meet up, gets us bands of light. Destructive, opposite points of the waves meet, cancel each other out. Now let's look at number 4. Explain how you know that electromagnetic radiation is a particle. So now we're looking at electromagnetic radiation being a particle. So in this case, in the electric effect, showed that electromagnetic radiation of a certain frequency shining on a piece of metal could cause electrons, which are negatively charged subatomic particles, to pop off of the metal. And we know that waves interfere with waves and particles interfere with particles, showing that electromagnetic radiation is a particle. So explain how you know that electromagnetic radiation is a particle. In the photoelectric effect showed that the electromagnetic radiation of a certain frequency shining on a piece of metal could cause electrons, which are negatively charged subatomic particles, to pop off of the metal. Waves interfere with waves and particles interfere with particles, thus showing the electromagnetic radiation is a particle since it was interfering with the electron, which is a particle. So then we go to number 5. Explain wave-particle duality of electromagnetic radiation. This one kind of combines the two together. So with all the information I've given you now, I would go in a lot of detail with this one. see, how can we word it? The interference pattern caused from the constructive same points, which is the same points on opposing waves, and destructive, which is opposite points on opposing waves. So the interference pattern caused from the constructive interference in the double slit experiment showed that electromagnetic radiation is a wave, while the photoelectric effect showing electromagnetic radiation interfering with
Jackson West to the office.
and causing electrons to pop off of metal show that it is a particle. Since we have evidence for both, suggest that electromagnetic radiation is both a wave and a particle. So explain wave-particle duality of electromagnetic radiation. The interference pattern caused from the constructive, the same points on opposing waves, and destructive, opposite points on opposing waves, interference in the double slit experiment showed that electromagnetic radiation is a wave, while the photoelectric effect showing electromagnetic radiation interfering with and causing electrons to pop off of metal showed that it is a particle. Since we have evidence for both, suggests that electromagnetic radiation is both a wave and a particle, thus giving us wave-particle duality. And number 6. Oh, 6 is a good one. So apparently I did not, I'm sorry I messed up. I thought I'd asked you about that interference pattern, what caused it with the constructive and destructive interference, but I threw it in here. The constructive interference is from the same points on opposing waves, and destructive is opposite points on opposing waves interfering with each other. If you got more questions, just ask me. If you got more questions on any of these, just come ask me. Feel free to come at lunch, and we'll be happy to answer those. So explain why wavelength must be in meters when using the wavelength equation. So when we look at using the wavelength equation, wavelength must be in meters when using the wavelength equation, because the constant for the speed of light is in meters per second. Both have to be in meters in order to be like terms and to be able to do the calculations. So this is the same thing with why we're constantly doing all these conversions that we're doing in chemistry. So with the wavelength equation, what I'm talking about with the wavelength equation, so you know what I'm talking about. Some of you may not know, this is the wavelength equation. It's C equals wavelength times frequency. So this right here, lambda, that's wavelength. See if I can clean it up some. So here's wavelength, and the problem that we have is the speed of light, c, is 2.98 times 10 to the 8 meters per second. Since it's in meters, We also have to have the wavelength in meters to do any calculations here, because if not, then they're not like terms, so they won't be able to cancel each other out. So the wavelength must be in meters when using the wavelength equation, because the constant for the speed of light is in meters per second. Both have to be in meters in order to be like terms and to be able to do the calculations. So hopefully this helps you guys out. If not, if you got any questions on these, please feel free to watch videos as much as you want, but come ask me, okay? Very approachable, I don't care. Come ask me. I want to help you, especially before you get this quiz. You have to be able to explain the concepts. You guys are doing okay at the math part. The conceptual explanation parts are where we're struggling. I'm seeing some of y'all get better at it, and let's just keep working at it. If you have questions, come see me. Besides that, have a great, wonderful rest of your day.